Hi, this is a project for 15821, and our project is on wearable time machine. The team comprises of Abinaya, Nirav, and me, Shilpa. We were mentored by Junjue. So this work is for imagine humans are not good at remembering names. So in a social setting, you often have people and you see people and you like, oh, I remember, I almost have his name on my on my lip, but you can't recollect him. So we have developed an application which helps in recognizing people, and it gives informative cues of when did you meet this person last, and some other informative cues that can help you in interacting with that person. So what we have is a mobile phone app which which takes in the video and sends to the server which does recognition. You want to
Like Shilpa mentioned, our aim was to create an Android application which is capable of providing intelligent social cues in a social setting, and the goals were providing the name of an identified person, his interests, and also the details of the most recent interaction, like such as the location and the time. We also want to be able to determine whether a person is important to the user, and to do this both dynamically and automatically. And finally, it should impose a minimal cognitive overhead on the user. So he should be able to interact with the user with the system without expending too much of his cognitive ability. So here we have the system architecture. We have four major components: the mobile UI, which is responsible for facilitating interactions with the end user; the face detection and face tracking, which is responsible for demarcating faces in an image frame, and then making cross-frame associations between these demarcated bounding boxes. Then finally, the next thing we have is the backend, which comprises of a deep neural network, which performs feature extraction. So given a face, it represents it as as a vector in high-dimensional Euclidean space, and so it also performs classification. So given a set of faces, it recognizes whether a face belongs to any of those classes. And finally, we have a known persons database, which is a MySQL database, which provides face-to-name associations. So given a face, it tells you, what the associated name is. And this pipeline is kind of fragmented between the mobile domain. So you see that we run obviously the mobile UI as well as the face detection and tracking on the mobile device, and the more compute-intensive parts, such as the deep neural network classification, as well as the known persons database, all of these reside on the cloud. And as you can see, the critical path obviously comprises of performing detection and tracking, offloading these frames to the server, and receiving the results back. But using this tracking component lets us essentially circumvent the critical path. So using this component, we can short circuit this long path. And the idea is to hide the latency of recognition behind multiple face tracking frames. So we can project the output of recognition onto tracking, since we know, since the tracking persists across multiple frames. And I'll hand it over to Abinaya to talk about the features of our system.
Hi. Adding on to what Nirav and Shilpa said, if you look at the features of our application, we have some add-on features like apart from like adding a person as a contact list, we can actually fetch details which are publicly available about that person using social media. Like for example, in a professional setting, you can always go to LinkedIn and find the publicly available data of that person. And the next time you meet that person, along with the name and the organization and the user inputs, it also displays the details like the interest and the education and the company and the designation the person is in. So that's kind of a very interesting feature we have right now. You can view the list of known people, and we can actually have a concurrent multi-user recognition and training in the same setting. So that's kind of, yeah. We can also show a small demo.
So
here we're mirroring the output of the mobile. Here we're mirroring the output of the mobile phone to the screen. So as you can see, so Abinaya is not currently in the database. So being in the frame long enough, the system determines that she's a candidate for a person who's important to the user. And you can see here that the system decided that this person might be important, so it added her to this carousel at the bottom. And now Shilpa, manually enters the details of this person. So the name and the organization. And now, when the next time this person comes into the frame, we're able to display the name, when she was last seen, so which corresponds to exactly now, the location, which is the Gates-Hillman Center, and it uses the name and organization to perform this simulated social media lookup. So based on the name and organization, we can tell that she's a master's student at CMU, and she's interested in distributed systems. So another feature is, if we have a list of all contacts we've looked at so far, and then if we click on any of them, we are able to either update them or add email addresses, etc. Or delete them from the database. In which case, she won't be recognized again. So that's the high-level idea.